Welcome, everyone. Welcome to our Bazel conference focused on our users and contributors. And we called it first annual Bazel conference because we'd like to do it again. And we'd like to do it again next year, maybe in a bigger space. This time we had to say no to quite a few registrants, but really excited to see you all here and to see how much interest we got from our community. And I'll take you through a little bit more about who we've got here. My name is Helen Altshuler, and I'm responsible for execution of engineering delivery for Bazel, and also leading several other programs within the build and test part of the developer product groups at Google. And I'd like to tell you a little bit more about this conference. We started planning it sometime in May, which is when Darren sent out a survey and got about 70 responses. And it's at that time that you told us that you were less interested in hearing from our senior leaders and more interested in hearing from each other, which is why this conference is packed with all of these talks. But that said, we do have our senior leaders, and I'd like to introduce them and point out so that should you have broader questions, you can speak with them. Melody McFassel, developer tools and signals director, and Jeff Cox, engineering director for build, test, and deploy tools here at Google. And you'll hear more from my colleagues directly involved in this talk as well. So with that, let's see who we are. But I really feel like Bazel is for everyone, and we're well represented by many, many industries here, fintech and autonomous vehicles from startups to large enterprises. We've got a number of AI companies and internet companies, software development companies, media, and so on. And I really feel like this demonstrates that Bazel is for everyone because it's a growing platform. It's an open source platform where you can make it better with us. I started my career developing in C++ with Makefile and trying to make sense of the ClearMake process, and really am a big believer of Bazel, especially given that experience. And I've noticed how easy it is to adapt, especially within the main language environments. So here's a small listing of companies. This is not everyone. Some of you didn't tell us that it's okay to put your company name on our list. But we do ask you to help us grow our user community and update your company name in our wiki at Bazel Build. And let us know and also let the community know that you're using Bazel. And of course, contribute. And now BazelCon by the numbers. We've got 240 plus attendees. There will be more coming, I think, tomorrow and also throughout the day. And from 65 organizations, and that's about 60 companies and more open source teams as well. We've got Kubernetes and TensorFlow, Abstraction, and a whole bunch of others. 30 presenters, schedule is listed, and Dave will cover that in a bit. And 20 talks. So we're very excited to see you all here and to spend time talking about this. So now, oh, and also what was really important to us was to make sure that our first user conference is really focused on people that use Bazel and care about Bazel. And as a result, we've got 60% of you actively using Bazel. Woohoo. We've got about 30% of you evaluating, which is great. We hope you will learn from each other, and this conference will help address some of the issues. We also have office hours, and schedule is posted outside as well as on our website, and we welcome you to come. This is where Bazel engineers will be able to answer your questions, maybe even do some debugging on the fly. So bring a laptop, bring your questions and problems throughout the day, today and tomorrow, and check the schedule by expertise on our website. And those of you, 9.1% of you who are curious about Bazel, we sure hope that there will be more follow-ups from this conference as well. And we'll probably need a bigger conference and bigger space next time. So now tell us how you use Bazel. So as I mentioned, Bazel is for everyone, and it's also very flexible and extensible with our Skylark language, which means you can use it on a variety of platforms and with a variety of programming languages. So let's start with the main ones. Maybe it's just kind of wake up morning routine. How many of you are using C++? All right, that's a big group. Java. About the same. Interesting. Scala. Smaller, but yeah, good presence. We've got a lot of community contribution on Scala, and you'll hear more from them. What about JavaScript? All right, and there's a talk on that as well. And how about the Python? Yeah, we know there's a lot of you, and we work in our Python story for sure. All right, and then what about language? What about platforms? So Linux obviously is one of the primary systems that many of our customers use. So yeah, that's all. Not that many of you, but yes. Apple. Okay, Mac. Any flavors? All right, and what about Android? Okay, and Windows. All right, so Windows also is represented in our office hours. Come by if you have questions. It's no longer experimental. It's just as beta as everything else in Bazel. But welcome. And to tell you more about Bazel, I'd like to invite John and Ulf, our engineering managers, and they will tell you how it all began and where we are. Thank you.
Mic drop, yeah, okay. I can't possibly follow that. All right. So it's great to be here. I'm John Field. I'm an engineering manager in New York. I manage the Blaze and Bazel team in New York. Somewhat unusually for Google, we have very little presence in the Bay Area, so we're all kind of visiting today. The German part of our team focuses on matters of efficiency, and the New York part of the team focuses on matters of style. No, not really, but we all do a little bit of everything, actually. So I wanted to, let's see if this works. Yes. So I want to tell you a little bit about the backstory behind Bazel, because I think it informs how we got where we are now, some of the struggles we went through to get things to work the way they do now, and this struggle may also inform how you are using and reacting to Bazel. So why does history matter? Well, Bazel's design evolved in response to actual problems that were encountered. People didn't just do this for the heck of it. Certainly one of those problems was Google's growth in terms of code and engineers, but also this set of platforms, tools, and languages that Bazel supports has continued to evolve over time. And so Bazel's design grew to accommodate that. So we believe that your evolution of your requirements is likely to be similar. So hopefully this story will resonate with you to some degree. So a couple disclaimers up front. I'm eliding a lot of details. I will tell a variety of smallish lies. Hopefully most of them are on purpose. A few I may have accidentally messed up something, and hopefully the rest of the great team here will correct me. I also won't, unfortunately, be able to single out all the awesome engineers who contributed both to the origins of Bazel and to its current set of functions. So in addition to this being a history, it's also a little bit of a love story. I joined Google about 6 years ago. I was working at the time on JavaScript tools, not on Bazel. And if you'd asked me when I was thinking of joining Google about working on a build system, I would have said, well, it's a solved problem. It's really boring. And besides, everybody hates it because they never work. So why would I want to work on such a thing? But after using Bazel's internal variant, Blaze, which you'll hear from in a second, I fell in love with it, and I realized it was an awesome system, and I'm really proud to have ended up on the team, and I'm managing part of it. Okay, so let's go back a little bit in time. So back around the early days of Google, Google had multiple projects from the beginning, but it was all of the code for those projects was in a single repo, what we now call a monorepo. And there were no development branches. The code was built at the time from head. The language world was pretty simple, mostly C++, Python, and Bash. And to build it all, there was a single makefile. And this actually worked pretty well up to the point where Google had a couple of hundred engineers. And then problems arose. So about 5 years after Google's founding, we realized that a single makefile just doesn't scale as the company was scaling. That's kind of obvious. However, there was a strong desire to maintain the ability to arbitrarily reference other projects' code from within your project. However, due to the scaling issues, we also wanted to hide a certain amount of information so things don't get completely out of control. So the solution at the time was to divide up the monorepo into what we now call packages, build packages. And the idea was pretty simple, but I think it's one of these things in retrospect, you don't realize how powerful it is until much later. So the simple idea of having a build file demarcating the root of a package, sort of tiling the depot, and then the build file contains a collection of targets, that is a set of things that can be built. And this is sort of the central abstraction around which Bazel has evolved. So most of you have seen this already. I'm not going to dwell too much on the details, but I think it's important just to remind everyone just sort of the ingredients of a build rule. So as you know, so consider a package, directory in the repo called foo with a build file, and let's say that build file contains a Java binary rule like the one you see up here. So rules are targets are instances of these rules. These rules are predefined abstractions, and they define how something is built, and then the name defines what is visible. So in particular, other build files can only reference from this particular package in this particular build rule foo, which is this binary, this Java binary which is built, which happens to also be in the foo directory, but it doesn't have to be. And then an implicitly defined output of the build called foo deploy.jar. So that's all that can happen. So in this little bit of code here, we have abstraction, we have information hiding, sort of the elements of a proper programming language, if you will, but it's embedded in the repo with everything else. And it happens to use Python syntax. But that has actually turned out to work pretty well, but over time. So rules are this critical abstraction, this critical declarative thing. And it's important to this, like all good abstractions, it hides just enough, but reveals just enough. So a rule defines what is built rather than the details of how it's using. So that allows the implementation details of a rule to evolve independently of some uses of that rule. It is a way of encapsulating best practices for generating code. So there may be certain obscure command line options your compiler needs. Well, you don't need to worry about those if you're an ordinary user. Somebody else who defines that rule is going to tell you what those abstractions are. It hides the details of build tools. So maybe you realize that GCC is involved, but there may be other tools in certain complicated build processes that you really don't want to know about if you don't have to. And it's a way of hiding those, certainly the details of how they work. A build rule also allows validation of the parameters before the build even starts. So there may be certain stupid things that the build system can call out and prevent you from hurting yourself before it actually starts invoking a whole bunch of tools. And finally, and probably most importantly, it's a uniform mechanism for precisely defining dependencies. And I'll get back to that in a second. So as this concept of the build rule evolved in Google, it became a single source of truth for software construction across Google's monorepo. And that turned out to be pretty critical. So there are a couple sort of smaller observations that I think the people working on this realized along the way. One is that build tools are also build artifacts. Okay, so tools can themselves be built. So things like compilers, linkage packagers, and so on, they can be referenced as binaries. They can be versioned with the repo, or they can be built from source as part of the build process. And at Google, we have traditionally done combinations of both, building the tools from source, from head, especially if they're evolving rapidly, or releasing them as binaries in the repo, and then only the latest version is available. So making build tools a first-class build artifact was a key observation that was made early. And in particular, that means you treat tools like any other dependency. And that's critical for correctness. Another key observation that the wise founders of the pre-history of Bazel came up with was the notion that a unit test is really just a form of tool. So what happens when you run a unit test? Well, you build the system under test. You build the suite of tests, the code for the test, say a JUnit test. You build a test runner, maybe, or maybe it's pre-built, but it's a build artifact itself. And then that test runner loads and runs the test suite, the system under test, and generates a log. Right? So this is really, abstractly, a test is really no different from anything else that is built. In particular, test outputs, particularly from unit tests, which are usually repeatable, is just another build output, and therefore can be cached. And that gives you a lot of power in building CI around a system like this. So I want to get back again. Well, let me just stop for a second and point out, I haven't talked about Bazel at all yet. And in fact, what I'm talking about predates the existence of Bazel. It was a set of concepts that was developed independently and predated Bazel. So that's why this concept of a build file and a build rule and target and so on is so important. So by adding this extra level of abstraction, build rules, this was a key. This gives us the ability to define dependencies precisely. Right, so that's a key for correctness of builds. You have no implicit flow of information that the system that's doing the build is unaware of, or it just happens to work on some platforms. Because the information is represented, dependency information is represented precisely in build rules. It's a key to performance, because if you know where all the information needs to flow and know accurately where it's flowing, you can parallelize things better and you can incrementalize things better. So correctness and performance really go hand in hand. It goes hand in hand because it's built on the foundation of precise dependency information. Precise dependencies allow you to trigger tests optimally only when dependent code is committed. It has other interesting side effects like allowing minimal release branches. So think of, as Google is growing and has this big monorepo, you want to do a release. You want to branch the code, vet it, and then push a binary out. Well, if you have to clone the whole repo, that's a pretty expensive operation. But if you know what all the sources your binary depends on accurately, you can immediately generate a minimal release branch. So there are lots of nice side effects and happy consequences of precise dependency information. Also, things like repo-wide refactoring tools are possible when you can track down all the dependencies that are affected by some code you're changing. It's possible to build analysis tools for code reviews that basically piggyback on top of the build system. So Google, as it has evolved, now does all of these things, but it took a long time to get there. It wasn't overnight. It wasn't like all of these things popped into somebody's head. This evolved in response to particular needs. So let's go back to that single makefile. What happened to that? Well, what it got replaced by is a tool called gconfig, and this was a shared script that generated makefiles from build files. And the logic for each build rule was implemented directly in Python and generated makefiles from Python. Users could also write macros, again, in actual Python, which expanded to rules. So the simple idea, but again, scalability problems start to arise by around 2006. So instead of having a single makefile, you're generating a makefile on demand for each build package. Well, the problem with that approach is the sum of those makefiles becomes quadratic in the size of the repo. And even in 2006, over 10 years ago, very large makefiles were not uncommon. The Python code that was used to generate these makefiles was slow. It was single-threaded. Python is notoriously hard to parallelize in any reasonable way. And then since it generated make files, there are the usual well-known problems with make, like not knowing to rebuild when a tool is updated. It didn't make doesn't know that have a distinction between tools and regular build artifacts. Stale output files that are no longer produced by rule could still be consumed by a downstream artifact, and so on and so forth. So all of the usual pathologies with make occurred, and then layered onto that were scalability problems with gconfig. Then there are other complications. So I painted this really nice picture of precise dependencies, all the benefits that come from that. Sounds really good. Well, it turns out when you're generating makefiles, people make shortcuts and people make mistakes. So the generated makefiles often contain hidden dependencies. Make semantics for scheduling actions is very conservative because it needs to worry about these implicit dependencies, or people often took advantage of implicit dependencies in order to ensure correctness. So even though we added this level of abstraction, its promise in terms of build files, its promise was not fully realized due to the way it was implemented by gconfig. Gconfig itself, as you can imagine, as Google is growing, also becomes a hairball of code. We need to support languages other than C++ and Python and stuff. Multiple hardware platforms arise, like think mobile devices and the complications therein. People start using IDEs more and more, particularly Java developers. It didn't play well with all the machinery we built around gconfig. So around 2007, now we're approaching, going from prehistory to history, a thing called Blaze is launched. And for those of you who know, Blaze is still the internal name of the tool that is externally known as Bazel. In 2007, somebody had this fabulous sort of 1970s font. This was an actual logo there. Sadly, we decided not to retain it for Bazel, but I think it's still pretty cool. It's sort of like maybe an 80s video game font or something. So at the time, there were lots of people around Google trying to fix this build problem thing that I've been mentioning earlier. So there are many competing tools, lots of interesting synergy between engineers working on competing technologies. I wish I could go into it. Maybe when we write the book or something, we'll go into the details. But Blaze emerged as the winner from a bunch of competing Google technologies. And they were all intended to address this gconfig scalability and correctness problems, but none of them proposed to get rid of the basic concept of build files, build rules, and so on. That was a successful concept. It was just the implementation was lacking. So what was Blaze? Well, it was a native implementation of gconfig build rules, native in the sense that it wasn't actually Python code anymore, even though the syntax of build rules was still Python. The implementation was now in Java. Python was actually still retained until very, very recently in Google, like 6 months ago, to generate what are user-defined build macros. So Python was only retired from our build system altogether quite recently. You've probably seen elements of this. I won't go into a ton of detail here, but it's important to mention that a key architectural decision the early Blaze developers made was to treat Blaze as a kind of compiler that takes build files and generates 3 logical graphs. Internally, the details are a little more complicated, but not much more complicated. So there are 3 key abstractions here. One is the notion of a target graph, which is basically just the obvious graph of build targets derived from build files. So that was made explicit in the implementation. Okay. There is also the notion of a configured target graph. So that was the realization that targeting different platforms, you might want to have the same code, but target different platforms or execute on different platforms. So the notion of a configuration is some contextual information that's added to the target graph, augments the target graph, and enables that graph to have additional information about where the code or how the code is going to be used. And finally, all of this is converted under the covers by build rules into a so-called action graph. And the action graph structure can look quite different from the actual the target graph, the configured target graph. But these 3 concepts, while they've evolved quite a lot under the cover, I think helped the architecture of Blaze scale and kept the sort of users conceptually honest in the process. Remember, Blaze at this stage was basically a compiler. Build files in, action graphs out. And once you have this action graph abstraction thing, you can execute code locally, which was originally the way Blaze was used, or later remotely. So these cores here could be local cores on your local machine. They could be remote cores because the abstractions were sufficiently strong that it was easy to move from local to remote. And I think that design decision has scaled pretty well. A few other key design decisions. The rule implementations could only access information via a constrained API. I talked earlier about configurations. It's a context in which a target is built. Caching is based on file digest. And since there was a well-defined notion of dependency, there was a tool called Blaze Query, which is Bazel Query now, which allows the user to get insight into the target graph. So just a couple other problems, and then I'll close my segment of the discussion. So Blaze has continued to evolve since 2007, over the past 10 years. And I'm just going to give you a few small examples of how it's evolved in response to problems we've encountered. So Blaze's original internal architecture, the actual details of the code, not those nice abstractions I gave you earlier, was quite complex. And it artificially limited opportunities for parallelism. So 3 or 4 years ago, a major effort was undertaken to completely refactor the internal code to use what is basically a fancy functional programming execution engine, which is parallel and incremental, called Skyframe. And if you look in the guts of the current Bazel code, you'll see lots of instances of Skyframe, and it's a very nice abstraction that's proven its value over time. Another problem we encountered was that Python preprocessing, which, as I said, until 6 months or so was still part of Blaze, became a bottleneck in builds. And adding new build rules required recompiling Blaze from Java source. So that was a problem as we wanted more and more users to contribute to the system. So we developed a dialect of Skylark, which was deterministic and parallelizable. Sorry, a dialect of Python called Skylark, which solve these problems. And it replaces Python for macros and Java for rules. And you'll hear more about this tomorrow, I believe. Some other problems. IDEs and certain classes of rules, like proto rules, needed access to information from an entire target subgraph. So it's basically augmented information in the rest of the subgraph. There was no good way to write such rules in the past. So we invented a mechanism called aspects. Aspects allow defining rules that recursively introspect other rules and allow users to extract metadata from the build graph for use in things like IDE integration. And that's our main IDE integration mechanism now that's proven to be quite extensible. Finally, there was a need to target multiple platforms again for things like mobile readily. However, such code needs to have platform-specific dependencies. So we added a feature to Bazel and Blaze that enables platform-specific dependencies to be defined based on the value of the configuration. So this is just a random example of the way Bazel has evolved from its early days in 2007 to the present. So where are we by 2015? Well, we have a lot of code. You can read the numbers here. I'm not going to go over them. And Blaze, the original, which is the code of which is now in Bazel, was working pretty well. And it scaled pretty well to 30K engineers. So in 2015, we decided, hey, we have something pretty good here. It stood the test of time. We're going to open source it. And we're going to call it Bazel just to be perverse. So why did we open source Bazel? Well, we really, I told you I was a convert to this whole build thing. And as a convert, you want to evangelize. And lots of the team wanted to evangelize. So we wanted to tell the world about what we thought was a really cool system. We wanted to benefit from insights of non-Google users and experience and platforms that Google doesn't know about, but might want to use in the future, like Scala. Someday Google may use Scala extensively. We don't now. But if we do, we'll benefit from people who've contributed Scala rules. There were an increasing number of open source projects in Google that wanted to use, and that Google wanted to use, where having the same build system work internally and externally, more or less, was a big advantage. And finally, we wanted to foster an ecosystem of allied tools like execution services, CI services, analysis tools, and so on, around the notion of a build graph. So now Blaze and Bazel evolve together. Most of the code is shared. And features designed for Bazel benefit Google and vice versa. So for example, the Windows port, which was basically requested by our users, is now used inside Google. The same with the Mac. I can mention any number of other features which external developers push us to add, which are now widely used in Google. So with that, I will turn over the baton to Ulf.
Hi, everyone. My name is Ulf. I'm the tech lead and manager for the Blaze and Bazel team that is the part of the team that's based in Munich. I joined the team 8.5 years ago. I joined Google 8.5 years ago. And so on my first day, there were 2 teams at Google who wanted to have me as an engineer. And so I went to the manager of the first team, and he was sitting at his computer. Yeah, you want to join my project? Oh, it's really cool, but you have to like it. And then I went with the other manager into a meeting room, and he said, OK, I'm going to show you how Google builds software. And on his laptop, he started to build up one of the Google services. And then he went to the whiteboard and said, while I'm building this, let me show what's actually happening underneath. And he drew up this fairly large distributed system. We were already doing distributed builds at the time. And I thought, whoa, that's cool. That's what I'm going to work on. And I love it. I've been here for all that time, and I really like my work. So there we go. I want to talk about sort of the largest topics, sort of the most important topics. I've tried to narrow it down to a couple of topics only, and sort of where are we right now? What's happened recently? That sort of thing. Skylark is, as John mentioned that already, Skylark is really a full programming language. And we are in the process of cleaning that up and making it a really well-specified language. We are starting to see adoption of Skylark outside of Bazel. For example, Buck is experimenting. Buck is a build system built by Facebook. They are experimenting with Skylark. One of the opportunities here is that if Buck's implementation is sufficiently compatible with Bazel, then some of the rules that we're currently writing for Bazel may also be used for Buck. Another project is Capybara, which is an open source tool built by Google, and they're using it to configure how to move code between internal and external, right? We have a lot of open source projects at Google, and sometimes they need to have slightly different code internally than externally, and so they use Capybara to sort of push changes in and out both directions. So if you are interested in Skylark as a language and also in what you can do with it in Bazel, check out Laurent's talk tomorrow at 9:30. Remote execution. We believe remote execution is one of the biggest immediate benefits of using Bazel. It works on Linux today. We believe it should be easy to run a distributed execution and caching system in the cloud or on-premise with a standardized API. We've recently invested some time, and unfortunately that was basically just before the conference, so we aren't able to talk about, we didn't manage to put in a talk about it. But we've been working on some prototypes and models to improve the current protocol. And some, just very briefly, in order to do remote execution, you need both high bandwidth and low latency to get good performance. You need to reduce round trips and chattiness where possible, because Bazel can fire a lot of data over the pipe, right? It can really put a lot of pressure on your network. And Bazel should avoid downloading output files if possible. For example, by only downloading them on demand, or by only downloading the results of whatever you want to do. If you run tests, then maybe it's enough to just download the test log and the result. Beyond that, we're also going to work on remote execution for Windows and Mac. We want that for ourselves, if nothing else, but I'm sure there are people here who would also like to have that, including cross-platform remote execution, which means Bazel runs, say, on Linux, but can run a build on Windows. I really want that for my daily work, where I make a change and I want to test, check that the test I write processes on all three platforms. If you want to know more about the upcoming API changes or experiments, talk to Jacob and Philip, who are sitting here in the front row. All right, so in order to use remote execution, you also need a service that offers remote execution. There are currently 2 implementations that we know of. There is a build farm project, which is an open source project. Contributors include Uber, Twitter, 2Sigma, and some support from us, of course. George has been writing a lot of the code. George is in the back there. And of course, he and Alpha have a shared talk about remote execution service at 9:45 today. There is also an experimental Google-hosted service that is already in use by some of Google's open source projects, and we're exploring offering that externally as part of Google Cloud. All right, federated repositories. So while I believe very strongly that a monorepo is the right way to develop code, not everyone shares that belief, and I'm fine with that. And that's one of the reasons why we added these workspace files, which allow you to configure your repository and download code, dependencies that are necessary to build your code. And I think we're going to call this federated repositories. Maybe not. So far, we've been calling it external repositories, even though sometimes they aren't really external. You can actually point, to code in your own tree. And anyway, there are a couple of problems with workspace files, and I wanted to give a heads up to everyone that we're looking into changing them. How exactly is still TBD, but if you have any questions, concerns, wish list, please do let us know. So what are the problems? Automation is problematic. If the workspace file is Skylark, so it's like a program, and automatically modifying a program to do something different turns out to be not so easy. But that's something that a CI system may have to do, right? You might, in your CI system, you might want to run against head of your dependency or against a specific version of your dependency. And so your CI system needs to be able to move your dependencies around between different versions. how do we handle floating dependencies versus locked dependencies? Right now, we sort of encourage people to use locked dependencies to specific versions, but that means that every time the dependency changes, you need to update and so on. And we're still figuring out, we think we can do better. We need to figure out how to do that. There's also, workspace files are sort of tightly integrated with auto configuration. And auto configuration is something that we absolutely want to have, but if you combine it with remote execution, you need to configure not for your local machine, but for the remote machine. And that's not easily possible today. And so that's also something we want to fix. And a couple of smaller things, integration with third-party managers. What about transitive closure dependencies? If your dependency adds another dependency, do you need to update your workspace file or not? Hopefully not. All right, platforms and toolchains. I was told this morning that the documentation for this has actually gone live last Friday. So feel free to look at the documentation. A platform is sort of a description of where code is running. A platform could be a Mac OS machine with a specific version of Mac OS and sort of a set of standard libraries on an x86 64 machine, for example. A toolchain is a set of tools and configuration that are used to perform a set of related operations in a build. Sorry for being a little bit vague here, but one example is a C++ compiler and linker for, say, x86 or for PowerPC. And so we want to make it easy to add new toolchains to the process so that you can target a wide variety of platforms, and also, make it easy to add additional platforms that you want to target, right? In many cases, hopefully, there will already be a toolchain that you can just use off the shelf, and we actually have people working on that. But in general, you should be able to say, I want to build for Mac, Windows, and Linux for this Ubuntu version and this Windows version, and then your remote execution should be able to figure all that out. And Bazel. All the rules will have to be updated to support platforms and toolchains. If you're interested in this, check out John Cater's talk at 11:30. John is sitting over there. The build event protocol. Please, please, please do not parse std out or std error. We now have a protocol that should give you all of the information that is currently printed to your terminal and a structured machine-readable format. Please use that if you if you want to work on CI system integration with Jenkins or whatnot, on IDE integration, or if you want to share build results between developers, for example, to reproduce someone else's build for debugging or analysis, that turns out to be a surprisingly useful thing to be able to do. Please do use the build event protocol. We previously had in Blaze, we had 4 different protocols that we were using. They're all not open source, but there are still some hooks in the code base. So if you see code that is unused, please ask us first anyway, because it may still be used for that. We hope to delete all of that code as soon as we can. As soon as we have moved all of our internal services to use the new build event protocol, we're going to delete all of that code. We're very much looking forward to that. And with that, I'm handing over to David. Thank you. Thank you.
Hello. Hi, my name is David Stanke. I'm product manager for Bazel. I'm very excited to see everyone out here today. Hello, community. I'm going to speak briefly about what's next, what's coming up. So first of all, we recently made a change to the release process. We're now doing a monthly release train, and as opposed to gating versions on features. So this should be pretty familiar from other projects that you've worked with. But basically, at or about the first business day of the month, we cut a new candidate. And at that point, we are frozen in terms of features. No new features for 2 weeks plus. When we hit 2 weeks and have 2 days within that with no regressions, we release. And you'll find the releases on GitHub under other releases pages with copious release notes. And then we've got a little wiggle room in there before the next cycle starts again. If needed, we hope not, we can do patch releases towards the end of the month. Again, no cherry picks for features. We're going to be pretty strict about that because we want to really have stability and we want to move on to the next version. You might notice that it's right about the first business day of the month. And what you'll find is that version 0.8 has just been cut and has some cool stuff in it that I will talk about in a moment. If you do want to run the very latest cut, bugs and all, you can find those nightly builds at ci.bazel.build. If you want to be running from the release candidates, look for those on the Bazel Discuss mailing list, or stay on GitHub on the latest stable version. So some of the recent things that have happened, as we mentioned, Windows is out of experimental, and I know some people here are using it heavily. Thank you. If you are a Windows user and have requests for us, want to engage with us, our team would love to talk to you about and understand your needs. We want to make sure that we keep advancing Windows in feature parity with the rest of the platforms. Speaking of platforms, from a different angle, the platforms descriptors, platforms and toolchains that Ulf described is now incorporated into the release version of Bazel. As of version 0.8, you can start updating your Skylark rules. And the documentation is live. This is going to be an evolving topic over the next few releases. So please read it. Please give us feedback, again, at the mailing list. And please check out John Cater's talk tomorrow on platforms at about 11:30, I think it was. And we'll be continuing to dive into that. A lot of Skylark cleanups. And I'm sure everyone has their favorite Skylark bug or is interested in the Skylark sandwich for your various languages. If you don't know what that is, it means that the ability to call native rules from within a Skylark rule has unblocked a lot of things. Cool new CLI, which is called experimental, but is now on by default, and has improvements. I actually don't know much about it, so I'm eager to learn more about that one. And then Skylark, as you see. So we've added the ability to do coverage within Skylark rules that are targeting the JVM, and other Skylark tools like there's a linter, a memory profiler, and a debugger all in flight. I think not quite released on all of those, but we're really looking to mature Skylark and the tooling around Skylark. Going forward, big thing on our mind is migration tools for various languages. Obviously, this is all very language specific. Something we'd like to do is mature that to have general principles around migration that are applied to the languages. Some of these are a little messy right now. Some different tools that overlap. We want to bring that together to help migrate both your third-party dependencies as well as your first-party code, make it easier to get your team onto Bazel. Recursive workspaces has been a long desired topic, and that means the ability to have a workspace that inherits the workspace of its dependencies. And that's something that we're picking up and hoping to get into Bazel soon. I don't know the status on that one, so please let us know if you're interested in collaborating on it. Again, more about Skylark, including a testing framework for Skylark. Android, we are on the cusp of releasing the integration and roboelectric tests frameworks for Android to make sure that you can do deep Android integration with Bazel. iOS testing as well, which not currently you can build but can't test today, but it's coming out. And then there's some cool improvements on caching, especially including caching of your third-party external repos can use the local cache. So we're all about fast and correct and fast. So now, as the road to 1.0, 1.0 means more than just a grab bag of features, right? We believe it means a certain level of maturity. So one thing that's a high focus is stabilizing all of the APIs and versioning them. A lot of features that are being deprecated, you'll see with every release a list of incompatible changes. And this is things that seemed like a good idea at the time. With basically every case as I've ever seen, it was replaced by something cooler and better. But please give us feedback if you think that we're taking away something that you depend on. But we're looking to rapidly mature and deprecate the things that are no longer in use so that 1.0 can be a stable API. When we hit 1.0, we're going to introduce semantic versioning so that the only a major release is something that will change an API. And then moving beyond that, we want to be able to create a long-term support version at 1.1 maybe. Haven't defined that whole story yet, but of course at that point, we really have something you can depend on, bundle into other software, etc. And please let us know if you'd like to participate in defining that long-term support policy. Some resources for the community. If you need help using Bazel, start at Stack Overflow, please. Submit your question there. Thank you, a huge thank you to everyone here who contributes to answering questions on Stack Overflow. You guys are a big part of making that the best resource. And if you have a question, start there. We also have our discussion group, which you can get to at g.co/BazelDiscuss. And that's a place to post topics, ideas. Hey, wouldn't it be cool if Bazel did such and such, and have a conversation around that.